All right, so here we are. We're starting again. I'm looking at circles. So first today we kind of just want to talk about some features of circles, and then we want to just worry about circumference. We don't really want to talk about area just yet. That'll be section 10.7. All right, so a circle, the definition of a circle, it's the set of all points equidistant from a given point called the center. So a circle, if I have a point here, all these points right here are, if I drew it well, they should be equidistant from the center. When we name a circle, we do a little dot, like a circle with a little dot in the middle, and then whatever the center point is, that's the letter that we use. So this one is circle C. A diameter is a segment that contains the center of a circle, and it has both endpoints on the circle. So if you think about it here, there'd be infinitely many diameters because there's infinitely many lines that I could draw through here that would go through the center and have the endpoint on the circle. All right, the radius. So a radius is a segment that has one endpoint at the center and the other on the circle. Congruent circles are circles with congruent radii. And then a central angle is an angle whose vertex is the center of the circle. So if here's my center of the circle, if I make an angle like this right here is a central angle. So if I had a angle like this, and the vertex is not the center of the circle, that is not a central angle. So the vertex of that angle has to be the center of the circle. A semicircle is half of a circle. So I'm going to put some points over here in this open circle here. This is going to be circle O. So that's in the center there. There's point A, B, C, and then D there, okay? So half of a circle, so I try to draw this, let's see here. Actually, let me move A over here so it's a little bit more, you know, it looks like it definitely makes a semicircle with C. All right, so I moved A over there. So a semicircle is half of a circle. When we name it, you're going to use like a little arc symbol in the top if you remember what we did when we named lines. So you're going to use a little arc symbol, and you want the starting letter, so one of the endpoints of the half circle, the semicircle, and then I want to end it with the last endpoint. So I could call it arc AC, but the problem with that is I wouldn't know what direction I wanted to go. So I'm going to use a third letter. So if I'm talking about arc ABC, I'm talking about this semicircle right here. If I go ADC, I'm talking about this semicircle here, okay? So you can use two letters. So you could use 2 or 3 letters when you're naming these arcs. But you probably want to use that third letter if you need to figure out what direction you're going in. So a minor arc is part of a circle that is less than a semicircle. So to name it, so as an example, AB would be less of a semicircle. Note here, arc BA is the exact same thing as AB, so it doesn't really matter. I'm just referencing the same thing. Arc BC, or again CB, that would be a minor arc because it's less than a semicircle. DC, or again we could call it CD, that would be a minor arc because it's less than a semicircle, okay? A major arc is part of a circle that is greater than a semicircle. So if I say ADB, so I start at A, go through D, and come over to B, that is bigger than a semicircle. I could go the other direction. So I could say A, B, D. So now instead of going this way, I'm going to go around that way to get to the arc. Okay, so you could also do it that way. All right, so here in this one right here, we want to name major arcs, minor arcs, and semicircles. So the semicircles are kind of easy. This is a diameter right here, so we could have the semicircle that goes this way. So that would be RSP. Again, you want to call that PSR, that's fine. It's referring to the same semicircle. We also have the one that goes this way. So we have RQP, or you could call it PQR if you wanted. Again, if you notice, I'm using that third letter there in the middle so you know what direction I'm going. If I just write RP, you don't know which arc I'm talking about because there's too many there, okay? So that's why it's not good to do that there. Your major arcs. Well, let's do the minor arcs. Those are also easy. So minor arcs are less than a semicircle. So SR would be a minor arc. SP would be a minor arc. PQ would be a minor arc. QR would be a minor arc. Let's see here. SQ would be a minor arc. Oops. And I think that's it. I think there's only those 5. All right, the major arcs. This one is actually a little bit kind of tricky to see them all. Maybe I'll use lots of colors here. All right, so the major arc. So this one right here, if I go around this way, so I could call that one RSQ. I could call it RPQ. It just tells me it's one of the endpoints is R, one of the endpoints is Q, and it goes through S. Like I said, if I want to put P there, that's fine. It also goes through P. Okay. Let's see here. This one right here. So this one we could call PQS. Again, the endpoints are P and S, and they go through Q. If you want to call it R, that would be. If you want to put R there in the middle, that would be fine too. Let's see here. There's this one. So we have R, I could call that RQS. So it starts at R, ends at S, again, or you could say starts at S, ends at R, but it goes through Q, or if you wanted to call it P, that's fine too. Let's see here. There's this one. I don't think we got that one yet. PRQ. So it starts at P, goes through R, comes around to Q. I got PRS. Got RQS. I think there's one more. I'm just missing it right now. You guys at home are like, you probably can see it and I just can't see it yet. I got this one. I got the PQS. We got the PQR. Got that one. All right, maybe there's only 4 of them. All right, well, there might be another one. If there is, you can always let me know later. All right, so anyways, let's move on. It's just kind of hard to find them because they're always so overlapping and then you're struggling. Don't worry, nobody's going to ask you a question to list every single one of them. That would be kind of crazy. I might ask you to list like 1 or 2. All right, moving on. Okay, there's something called arc measure, and then later on we're going to find something called arc length. They're 2 different things, so don't get them confused. When I ask you for the arc measure, that's always in degrees. The measure of the minor arc is equal to the measure of its corresponding central angle. The measure of the major arc is the measure of the related minor arc subtracted from 360. The measure of a semicircle is 180. So in this one right here, what this is saying is the measure, if you notice I'm using a little m there, like kind of like we did with our angles there. So the measure of arc, RT, it says up here, the measure of the minor arc is equal to the measure of its corresponding central angle. So the central angle is 50, so it's 50 also, okay? If you can put the degree symbol there, you don't have to since we have the word m there. So the measure of a major arc, what this is saying, so this arc right here, RQT, it's 360 minus the 350, so I get 310. Okay, and I don't have a semicircle here. All right, adjacent arcs. Adjacent arcs are arcs of the same circle that have exactly 1 point in common. The measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. So all this is saying here, so here's a circle here. I've got A, B, and C all on the circle. So it's just saying that the measure of arc AC is equal to the measure of arc AB plus the measure of arc BC. All right, the next example, it says find the measures of the arcs in the circle. There's lots of arcs in here. This is supposed to be P. So I want you to find the measure of arc PR, find the measure of arc RS, and find the measure of arc PQ. So you can pause the video, unpause it, and then when you're ready to see my answers. So that's what you should have for that one. The PQ one, I'm referring to this one right here. You know that this is 77, this is 28 right here. You found this one, this is 180, so you already know that that's 103, so then you just have to subtract everything from 360. All right, your circumference is your distance around the circle. And pi is the ratio of the circumference of a circle to its diameter. So if I asked you what the formula for the circumference was, I'm going to come back to this. So if I asked you for the formula for the circumference, you would tell me pi d probably. So what it's saying here is if I divided both sides by d, pi just ends up being equal to the ratio of the circumference divided by the diameter. All right, so it says here the circumference of a circle is pi times the diameter. Sometimes you all know the diameter is the radius times 2. So 2 pi r is also another formula that you can have for circumference. Concentric circles are coplanar circles with the same center. Kind of like a bullseye. So like they're just kind of on top of each other like that and they have the same center. All right, this next example here. So it says that we're finding the distance here. So it says a car has a circular turning radius of 16.1. The distance between the two front tires is 4.7 feet. How much farther does a tire on the outside of the turn travel than a tire on the inside? So to start you off here, you might be a little bit stuck here on how to even draw this picture. So here's my car. And basically what it's saying here is that outside radius there, the turning radius is the outside radius, so it's 16.1. And then you know that the distance between the car's wheels are 4.7. So you want to know how much further do these outside tires travel versus these inside tires. So I'm going to find the circumference of the outer circle. So again, when I'm finding that outer circle, I am finding the circumference that goes this way, okay? The outside one. So then that one, so I'm going to use 2 pi r. So in this case, I'm going to use the 16.1, okay? That ends up being, so if you're not familiar, on these graphing calculators, there is a pi button. So you can do 2, and then the pi is above the caret. So if I hit second, and then caret, and then 16.1, and then I get that answer right there. If you're on your phone, you should also have a pi button on your phone calculator, again, you're going to want to turn it sideways. So 2 times pi, it's right down there, times 16.1. So you can also get the answer on your phone calculator as long as you're using the scientific calculator. All right, now I want to find the radius of that inner circle there. So the circumference of the inner circle, I want to do 2 pi. And then this radius, though, is actually going to be the 16.1 minus the 4.7. Okay, so I'm going to come out here, 16.1 minus 4.7. I get 11.4. So this circumference is 2 pi times 11.4. Again, I do that same math, and I get that answer there. But the question was how much farther. So what I need to do with those numbers is I need to subtract them. And this was in feet, so it's about 29.5 feet further that the outside tire is going to travel. All right, that kind of is going to lead us into arc length. So arc length is a fraction of the circumference. So as an example, let's say if I had something like, here's my center right here, and this center angle is a 90-degree angle, and the radius is 3. So when I'm talking about the arc length, I'm talking about finding this right here. Well, if you think about it, it's a fraction of the circumference. So the whole circumference of this would be 2 pi times 3. That's the whole circumference. But I don't want the whole circumference, right? I only want a part of it. And if you think about it, I only want a quarter of it. Now, how do I get a quarter of it? Well, if I did 90 divided by 360, that's 1/4. So I really only want a quarter of it. If you, sometimes in these ones, you're going to be asked to leave your answer in terms of pi. So if I do 90 divided by 360, again, that's the 1/4, times 2 times 3, that's 1.5, which in a fraction is 3/2. So I could leave that as 3/2 pi. So in that particular one, I did not multiply the pi, because sometimes you might be asked to leave your answer in terms of pi. So basically what arc length is, so the length of an arc of a circle is the product of the ratio of the arc measure divided by 360 and the circumference of the circle. So again, here's your circle. Let's say that's point A and that's point B, and I want to find this arc length right there, and I know the radius. The arc length is going to be the measure of that arc, so whatever that angle measure is in there, divided by 360 times your formula for circumference. All right, the next 2 examples are pretty straightforward. So to pause the video, try them on your own, and then I will unpause it and you can hear my answers. All right, so for this one, to find the arc length, it says it's a semicircle, so it's 180 over 360 times 2 pi, the radius is 1.3. Leave your answer in terms of pi. 180 over 360 is 1/2, so then this ends up kind of 1/2 times 2 is just 1. So my answer in terms of pi is just 1/3 pi. Remember, I'm just talking about circumference. I'm not talking about area, so the units are not squared here. All right, the next one, it says arc length, and the arc is 40 degrees over 360. The radius is 10, and this one it says round to the nearest tenth. So that one you can just plug in your calculator. I got this crazy answer here when I rounded to the tenth, and it ends up being 7.0 inches there. Again, the circumference is just one dimension, so that you don't have to have squared units there. All right, so we're going to look at a couple of these homework problems. So we'll start with 32, 35, and then I'll do this last one here with you. All right, for 32, so just be aware that sometimes they're asking you, it says find the length of the arc shown in red. So they're asking you for the bigger arc there. So just pay attention to that. This is 90, so then the bigger arc is 360 minus 90, so it's 270. So then I could just do 270 over 360, and then 2 pi r, which is 18 here. I'm leaving my answer in terms of pi, so I would just do 270. So on my calculator, I can do 270 divided by 360 times 2 times 18, and I get 27 pi, and again, the units here are meters, okay? All right, we're going to look at 55. All right, so 55 says use coordinate geometry to find the length of a semicircle with endpoints of 1, 3, and 4, 7. So basically what the 55 is saying here is we have a semicircle and these are the endpoints. So this must be the diameter. So if I use these 2 points right there and I use the distance formula, I can find the length of the diameter. So if I do 1 minus 4 squared plus 3 minus 7 squared. So 1 minus 4 is negative 3, squared is going to be 9. 3 minus 7 is 4, 4 squared is 16. 9 plus 16 is 25. The square root of 25 ends up being 5. So the diameter is 5. That means the radius is 2.5. So then when I want to find the length of the semicircle, so I want to find this length right here, I know the radius now, so to find the length I'd have 180 over 360 times 2 pi and then 2.5. Now this one you can type all in your calculator. I have approximately 7.9 and I'm just going to write units there, okay? All right, the last thing on the homework one I'm going to go over is this little question right here. So this one says here, determine the measure of the minor arc formed by the minute and hour hands of a clock at 11:15. All right, so if we think about, like, obviously 12 is here, and then the 3 is the 15-minute mark right there. So the minute hand is going to be right on that 15-minute marker, right? And let's say this is 11 o'clock. So we have 12 hours here on our clock. So 360 divided by 12 is equal to 30. So each of these are equal to 30. So you might just want to say, okay, well, this is 1, 2, and 3. So there's 1, 2, 3, 4. So 4 times 30 would be 120. So that must be the angle there. But that's not right. Because think about if you look at a clock, when it's 11:15, the hour hand is not at 11. It's actually moved a quarter of the distance between here. So it's moved a quarter of the distance there. So it really only has 3/4 left to move. So you can think of it either way. So if I do 3/4 of 30, 3/4 times 30. So 3 divided by 4 times 30, I get 22.5. So that's how much is left here. Again, because it doesn't have to move the whole thing. It's already moved a quarter since it's at 3:15. But then I need to add that to the 30, 30, 30, so the 90 I have there, so then you end up with 112.5 degrees. Okay? Alrighty, that is it for 10-6.